welcome to Dynamite Nourishing Computer. Today's topic is about linked list and there we go.
Let's start with it. What is a linked list? A linked list is a very commonly used non-primitive linear data structure. It consists of group of nodes in a sequence. Okay, each of the node contains its own data and the address of the next node, and thus it forms a chain-like structure. Okay, so this linked list have a dynamic memory allocation, that is runtime memory allocation. That's why we don't need to know the size in advance. That is, the size is not fixed. It can easily be increased and it can also easily be decreased. Okay, so in case of linked list, what happens? The pointers are used. Why pointers are used? Because here data elements are allocated in memory at runtime. So the memory allocation can be anywhere. So that's why in order to access every node of the linked list, address of each of the node, that is to keep track about the next data about the next node, the address has to be stored in the previous node. That's why these pointers are used as references. These pointers are used as the link between every node. Okay. So now, in case of linked list, the insertion and deletion operation can be easily implemented just by interchanging the pointers because it has dynamic memory allocation. Okay, joining and splitting operations are also easy in case of linked list. That's why linked list can be easily used to implement the stack data structure and the queue data structure. Okay, one more thing. When we talk about arrays, arrays have a static memory allocation, that is compile time memory allocation. Size is fixed in case of arrays. Okay, that's why random accessment is possible there because that is the elements in case of the arrays have a continuous memory allocation. That's why easily the elements can be accessed just by specifying the index number. But in case of linked list, the elements are present in the non-continuous way. That means in the memory allocation, it is present in the non-continuous way in case of linked list. That's why random accessment is not possible. That's why each of the element in case of linked list is accessed in the sequential order, is operated in the sequential order. Okay. This is about the introduction of linked list. Now we will talk about the types of linked list. So there are three types of linked list: single linked list, double linked list and circular linked list. Okay, so what is a single linked list? Single linked list is that type of list where in each of the node there is only next part, that means the next part contains the address of the next node. Here only forward navigation is possible. Backward navigation is not possible. Okay, here there in case of linked list, one start or head node is compulsorily used because it keeps track about our first node. It keeps the address of our first node. Okay, so here I have taken one example, 1000, let's say 1000 is the address of our first node. So the start, that is the head node, contains the address of the first node. Then the next part of the single linked list, here it contains the address of the second node, that is 2000. Then here this second node contains the address of the third node. And here in the last node, next part, null value is assigned. Why? Because this means that no further node is present in this particular list. Okay, so this is the single linked list. Here only forward navigation is possible. Here further next node is not present, that's why null value is assigned to the next part of the last node. Okay, then we have the double linked list. Double linked list has two fields, that is one previous field, one next field. This can also be called as start field and this can also be called as a end field. Okay, so here also the start or the head node contains the address of our first node, that is 1000. Okay, so here what is happening is that, see, previous pointer is there, so here null value is, why is it assigned? This means, this states that here no means in the previous there is no node is present. That's why here null value is assigned. Okay, then 2000, that is the address of our second node. Here in the previous part of our second node, the address of our first node is stored, that is 1000. It points back again to the first node, and then that is the in the next part of the second node, address 3000 is stored, that is the address of our third node, and it again, that is here in our third node, in the previous part, address of our second node, that is 2000, is stored. Okay, and again in the next part of our last node, null value is assigned. That means in further no node is present. This is the end of our list. Okay, so in double linked list, forward and backward navigation both are possible. Okay, then circular linked list. Circular linked list is again divided into two parts, that is single and double. In single, what happens here, that is after this, in the last node, next part, instead of null, that is it contains the address of our first node. See here, address of first node is 1000. So in the next part of our last node, it contains the address of our first node. So after last, it connects back to first. Okay. Similarly, in double linked list, what happens? There is one pref field. So this previous field, instead of null, it contains the address of our last node. So from first, it is connect back to the last, that is the address of our last node is 3000, which is stored in the previous part of our first node. So it is from first, it is connected back to last. And in the next part of our last node, the address of first node is stored, that is 1000, that is first node address is 1000. So it is stored in the next part of our last node, and then from last, it is connected back to the first. Okay, so this is all about the introduction of linked list and types of linked list. In our further upcoming videos, we will be coming with more, that is conceptual videos on linked list. Till then, stay gold, stay safe, and thank you.
But we don't talk anymore.